Hello children, welcome back. Today we shall start physical science. In this, the topic we are going to deal is reflection of light yet curved surfaces. What is the name of the topic? Reflection of light yet curved surfaces. So first, let us see what reflection is. You have already learnt this in your earlier classes. Let me remind you this before we proceed to the main part of the topic. See, when you just hit a ball onto the wall, what happens? It bounces back. The reflection of light is also the similar kind. It is bouncing of the light ray when incident on a surface. This phenomena is called reflection. So the property of light ray, because of which it comes back after being incident on a surface, is called reflection of light. This is the complete definition. Whereas to understand it very easily, it is just something like bouncing of the light ray. As the light ray is incident on the wall or on any surface, it bounces back. It comes back. So that is reflection of light. But we are in class 10. So a proper definition has to be given for this. So the property due to which a light ray comes back into the same plane after being incident on a surface is called reflection. So reflection is one of the properties of light. That is one of the properties of the light. See, to go ahead, we are supposed to know few terminology. Opaque. What do you mean by opaque? See, when light is made to pass through certain substances, it can't pass through certain surfaces. Suppose if you take a book and then focus the torch on the book, you can't see the light being penetrated through the book onto the other side of the book. That means light cannot penetrate through some surfaces or some bodies. So such material is called opaque material, or such a surface is called opaque surface. What happens here? See, if you are focusing the light on a mirror, a silvered mirror or a polished mirror, what happens? You can see the reflection of the light on the same side. Whereas light cannot penetrate through mirror and you can't see the light coming out from the other side of the mirror. Light cannot come from the other side of the mirror. So what is happening in case of opaque surfaces? Reflection takes place. That is, reflection takes place. That means completely all the light will be reflected back. 100% of the light will be reflected back. If it is a pure opaque substance, that means on an opaque surface, right, on a surface or on a substance, if you incident light ray, that means if you focus the light, light cannot penetrate through this. That means through which material light cannot penetrate, or through which surface light cannot penetrate, such a surface is called opaque surface. Is that clear? Such a surface is called opaque surface. Examples, you can give wood, wall, very simple. On the wall, if you focus the light, you can see that it will get reflected back into the same plane, but it cannot penetrate through wall. Okay, so opaque. Now it is clear, right? Any surface which cannot allow the light ray to pass through it is opaque. Very simple way of saying is a surface which does not allow the light ray to pass through it is opaque. It can be a material, it can be a surface, or it can be a body. So it does not allow the light ray to pass through it. In this case, reflection is maximum. In this case, reflection is maximum. Here the reflection takes place maximum. Reflection is maximum. Right. The next one is transparent. Next one is transparent. Transparent medium means it allows maximum amount of the light to pass through it. A transparent material, matter, surface, whatever you call it to be. So a transparent medium, that means it allows the light rays to pass through it completely. It allows the light to pass through it completely. The best example, can you please give one best example for this? Yes, you are saying that it is glass. See, glass plate is transparent, but not completely, because you will be able to see the glass plate also. That means a part of the light which is incident in the glass also reflects back. It cannot completely allow the light to pass through it. If you talk about transparent material, in nature you don't have completely transparent material. That means you don't have a medium or a transparent matter or the surface which can allow 100% of the light to pass through it. But when maximum amount of the light is allowed to pass through it, then we call that medium or that surface to be transparent. Okay, so here also we say it is maximum only, not completely. Not completely. Now translucent. When it comes to translucent, that surface or that material or the matter allows the light ray to pass through it partially. We call it partially. So partial reflection as well as partial refraction takes place. That means when the light ray is made to pass through it, some of it will pass through it and some of it will get reflected back. So that is translucent. Okay, so you can say that a little bit of impure water is translucent, where you can see the surface of the water as well as beneath the water. Beneath the water you are able to see the objects, means light ray is able to penetrate through water and it is incident on the bottom, and then again it is getting reflected back and the reflected light ray is again passing through water and then coming out into the air medium. Okay, so translucent. Now next, polished surface and optically rough surface. Optically polished and optically rough surface. That means if the surface is very smooth, so as the ray is incident or as the beam of rays is incident, then this, in a similar manner the beam will get reflected back if the surface is polished. If it is a rough surface, okay, if it is a rough surface, let me explain it here. See, if I take a mirror, this is polished, very smooth, as well as it is silvered from back, and whatever the beam of rays, now that means if I take 2 or 3 rays falling on it, in a similar manner, they will get reflected back. They will get reflected back. So this is called polished surface. And now when it comes to rough, optically rough surface, it may appear smooth to your eyes, but when you keep the surface which you are thinking it to be polished under a microscope, you can see that the surface is very uneven. The surface is very uneven. So now when a beam of light ray falls on it, so this reflects like this, and here this gets reflected like this, and the light ray which is falling at this point will get reflected like this. See? So the beam is getting scattered. What is happening to the beam here? The beam is getting scattered. One is reflecting in this direction, the other is reflecting in this direction, the other is getting reflected in the other direction. So what is happening here? The beam is getting scattered. That is the meaning of polished and optically rough surfaces. You may ask me now, ma'am, how are you able to draw this? Based on what properties or what law you are able to draw these things? Now to understand this, we need to know few other things, few other concepts. Meanwhile, just go through what we have discussed, like the words what we are needed to know, and then here I go with the next words. So before that, again let me revise what we have recollected till now. Reflection, that is the light being returned back into the same medium after being incident on a surface. Opaque, when a surface allows maximum amount, when a surface does not allow the light ray to pass through it, or it reflects the maximum amount of the light, we call it to be opaque. Next one is transparent, a medium or a surface which allows light to pass through it is called transparent. So maximum light is allowed to pass through it and very minimum reflection takes place. So reflection, how much? Minimum reflection takes place. Minimum reflection takes place. And now translucent, partially. So that means this particular medium or the surface or the substance allows the light to pass through it partially. Means some amount of the light is reflected back and some amount of the light is allowed to pass through it. The next one is a polished surface, where whatever the light beam is found, made to incident on the surface, the same beam in the same manner it will get reflected back. And rough, which is optically rough, what we mean to say is, see, even the board appears to be very smooth here for your naked eye, but when it is put under the microscope, you can see that it is very uneven, the surface is very uneven. So what happens? The light which is falling on it will get scattered in different directions. It will get scattered in different directions. That is the meaning of being optically rough. Is that clear till now? Okay, now the next part is, what is a surface? Okay, any part of the body on which light is focused, we call that to be the surface. Very simple. Any part of the body. See, suppose this is the surface on which the light is falling or light is made incident. Right? Even your body, even my face, that means this part of the face It means light is falling on here. It is getting reflected back. So any part of the body on which light is focused, that part is called a surface. That part is called a surface. So now let me draw. Let me take the example of a mirror. It's very easy for you people to understand and imagine. So whenever it is a mirror, just draw a horizontal line and then you can see that small slant lines are drawn here, which shows that it is a representation of a mirror. Right. So mirror is optically polished, smooth surface, and now normal to the surface. What is the meaning of normal to the surface? Right. So now any imaginary line which is drawn perpendicular to the surface, means which angle it has to make? 90 degrees. Can you see this 90? Yes. So an imaginary line which is drawn perpendicular to the surface, that means which is making an angle of 90 degrees with the surface. Right? Yet that point where you wanted to study about incident ray and how it is getting reflected back. At which point you are drawing the normal? At that point where you wanted to study the behavior of the light ray. So let us suppose that I wanted to study the behavior of the light ray at point O. So I am drawing a normal here at point O onto the surface. Right? So now here, normal to the surface is now done. That means an imaginary line drawn perpendicular to the surface at the point where you wanted to study the behavior of the light ray is called normal. Infinite normals can be drawn here. Because if you take this as one single straight line, a straight line is composed of infinite points, and at every point you can draw a normal. So therefore I am limiting myself to only a single point, so point O, and at this point I am drawing a normal N. So I am naming it as N. Now incident ray. That means you have to imagine that a ray is coming and falling at point O. It is coming and hitting the surface at point O. How does it come? It comes in number of ways, right? In this plane, from anywhere it can come and hit the point O. Let me imagine. So let me take that my ray is coming like this. The ray which I have considered is coming like this. Let me name the incident ray as capital I. So my capital I is coming and hitting the surface at point O. At point O. This is my incident ray. So the ray which is incident on a surface is called incident ray. A ray which is incident on a surface is called incident ray. Now reflected ray. After the ray is incident, because what we have taken is optically polished as well as what is the silvered. Silvered means it is becoming opaque. So it has to reflect the ray. So the ray which again starts from O and moves back into the same plane. A ray which starts at O and moves back into the same plane is reflected ray. Now you may ask, ma'am, why did you draw it like this? Why can't it be reflected back? See, we are able to come to conclusions and we are able to frame laws based on our observations only. In the beginning only I said, if a ball is made to hit the surface, how it gets reflected back? In a similar manner, that means how it bounces back, in a similar manner the light behaves. So if you hit the ball like this with an inclination to the surface, then obviously the ball also bounces back with the same inclination. Okay, so that is the reflected ray. The ray which is reflected from the point where the ray is incident is called reflected ray. The ray which is coming back into the same plane from where it is incident is called reflected ray. So now, normal to the surface, it is an imaginary line which is drawn perpendicular to the surface, yet the point where you wanted to study the behavior of the light. Incident ray, the light ray which is made to incident or which is made to hit the surface at a point. Reflected ray, the ray which comes back after reflection into the same plane is called reflected ray. Let me name it as capital R. I am naming it as capital R. So my IO is incident ray, OR is reflected ray. Now here, incident angle. The next word what you have to learn is angle of incidence or incident angle. So this can be said as angle of incidence or incident angle. So now, the angle made by the incident ray, with the normal is called angle of incidence. It is not with the surface, please. Whenever you are studying the behavior of rays in ray optics, remember that angle of incidence means angle made by the incident ray with the normal. Therefore, it is very, very important for you to imagine the normal always. Okay. So, what is incident angle? Angle made by the incident ray with the normal at the point of incidence. So, this is the angle. So, this is, let me write it as I. Incident angle, small I. So, I made incident ray, capital I. My reflected ray, capital R. Normal to the surface, I have taken it to be capital N. So, angle of incidence or incident angle is the angle made by the incident ray with the normal. With the normal to the surface where the ray is made to incident. Okay, right. Now, the next one is reflected angle. So, angle of reflection. What is the other one I am saying? Angle of reflection. So, angle of reflection is again the same like how you have defined incident angle. It is the angle made by the reflected ray with the normal. Angle made by the reflected ray with the normal. Let me write it as small r. Let me write it as small r. Okay, so incident angle is I, reflected angle is R. Now you can see the picture. Now I have taken a mirror as my surface, right? And I imagined the normal passing through point O, and my ray of incidence is IO, which is making an angle of incidence, small I, with the normal. The reflected ray is represented by capital R here. So, ray, so therefore I will represent it like this, capital R. And now, this is making an angle of small r with the normal. So, either the angle of incidence or the angle of reflection, you have to always keep in mind that it is the angle made by incident ray with the normal as well as reflected ray also with the normal, but no way with the surface. You have to remember that one. So that is why to draw the normal is very, very important. Okay, so now we are done with the normal to the surface, incident ray, reflected ray, angle of incidence, angle of reflection. Now finally we are here with laws of reflection. Already while discussing this only, I was mentioning two things. One is how the ball bounces in a similar manner the light ray behaves. The second one is into the same plane, and keep on saying that the ray reflects back into the same plane. These two put together form the laws of reflection. The first law is angle of, with what angle it is coming and hitting with the normal, with the same angle again it will get reflected back. So that means very simply saying, you can say angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Then the second law is all incident angle, incident ray, reflected ray and normal. Incident ray, reflected ray and normal. All these three should lie in the same plane. Incident ray, reflected ray and the normal. All these three lie in the same plane. This is the second law of reflection. So whichever light ray you are taking, on whichever surface you are taking, all the light rays obey these two laws. So therefore we call them to be laws of reflection. We call them to be laws of reflection. What are they? First one is angle of incidence is equal to angle of reflection. Second one is incident ray, reflected ray and normal. All the three lie in the same plane. Is that clear? So, can you observe one thing? See, I have put the directions of how the ray is moving. See, incident ray is coming and hitting the surface, therefore this is how the arrow mark is. Reflected ray is moving back into the same medium or same plane, so therefore the arrow mark is away from the mirror. This is towards the mirror, this is away from the mirror. And where you are putting the rays, arrows, that only shows that they are rays, because in ray optics everything is in straight lines. So you can just simply say that without keeping these arrow marks, you can simply say that this is my incident ray, this is my reflected ray. So rays are supposed to be identified by everybody only by looking at the arrow marks. So drawing an arrow mark on a ray is the utmost important thing to be remembered. Okay, is that clear? So what did we learn in today's class? About reflection, opaque, transparent, translucent, polished and rough surfaces. Then normal to the surface, incident ray, reflected ray, incident angle, reflected angle, loss of reflection. Where loss of reflection, first law is angle of incidence is equal to angle of reflection. Second law is incident ray, reflected ray and the normal to the surface. All the three lie in the same plane. Yeah. Those who want to copy this can pause the video for a moment and then copy it, or you can also take the screenshot and later on you can copy it. Okay. This is all for today. Please revise the concepts properly so that it will be very much clear for you for the next class. See you again.